Hello, welcome everyone. So today is the commercial water heating session, and then we've titled it "Going Together, Going Further." So I'd like to welcome everybody to today's call. My name is Buba Jeme from the Consortium for Energy Efficiency, CEE. I'll be the moderator for this hour. And before we get started, just want to touch on some of the housekeeping rules to take note of while we're here. And then soon after, we'll move to our great speakers of the day. So first, I'd like to thank all our sponsors for today's for this conference and supporting the ACEEE and then all our ally members. I would like to say if you could use the chat box on the right side of your screen to ask questions. Note that the presenters won't be able to answer the question in the chat, but we'll be taking notes and then make sure we respond to it. And if we don't do it within this hour, we'll make sure we bring it up during the Zoom discussion that will follow after this. So also know that all the presentations will be available during the afterwards on demand for registered participants on the social platform. So so I hope you can take note and follow those afterwards. On to that today's call I'll be speaking briefly about the theme of collaborations, going, like as I said, going further, going together, which is from an African proverb. And then soon after, Colin Collins from Cadio will be talking about design guidance on the design of commercial water heaters program, and then some next steps. And then following with that from DNA International, we'll have John Morris talking about the market transformation roadmap for commercial water heating, looking at, I think, midstream programs. So with that, I'd like to jump right into my slides, a few slides that I have just to guide this session and get us started. Okay, I hope everybody can see this. All right. So like I said, my name is Buba. I'm from CE. For those who don't know, CE is currently the forum for utility and efficiency program across the country to work together and achieve higher impact. We represent about 70% of the $9 billion industry for energy efficiency. So you can imagine our reach and then the importance of we put on collaboration. We work a lot. We work with all the market players, and this is something that's been done for 30 years. This year we celebrated our 30 years. But the goal is always on resulting in more efficient products in the market being available to everybody, and also installed correctly so we can achieve the highest savings possible with regard to kilowatt hours, but also in terms of other climate-related goals. So I just shared a brief list here of lot of all the programs that are currently members, but also many of the partners we work with, which include the federal advisors from Natural Resources Canada, the DOE, EPA, but we also have national labs and other organizations actively involved in our committees, in our discussions. And with that, I want to touch briefly on our current, which is the initiative revision for our commercial water heating programs. We have a current program that's been around for 10 years now. And at the time, for many of you might know that we didn't have efficient electric water heating systems, especially. So the program, the initiative mostly focused on gas tankless and gas storage system. But with all the advances we have now, including heat pump water heaters, we have decided to revise the initiative and make sure we include electric and gas heat pump water heaters. And also additional features with regard to connectivity to enable additional benefits and savings and across the board. But we understand that installing the equipment alone or having efficient water heating equipment alone is not enough, although it's necessary. We also understand that we needed to use a system approach to defining efficiency or to installing the systems. And we have a few strategies that we're working on in achieving that. And we kind of develop all of that in collaboration with our industry partners along the way. So I just want to give you a brief overview of that, and come to how we connect all of us can interact in the market with our partners like Cadio, or our members partners like Cadio or DNL to move the market forward. The current initiative we have in place include 4 main components, which are we have a definition of what specification definition for water heating equipment, going from storage, tankless, which we've kind of moved the limit a bit higher, and then including heat pump, gas, and electric, based on the DOE current standards. And then we also have an optional connected criteria that is included, because we knew in the journey of heat pump installation in the US and Canada, we basically have a few guidelines or suggestions that are based on market lesson learned so far from the program, but also the pilot programs and manufacturers and other market players, or especially researchers. So the initiative comes with a specification, but also guidance to support a proper installation of systems. And then in addition to that, because we're going towards a global system efficiency metric or approach, we have suggested a performance data reporting, so we can understand as a group, as a collective, what are the lessons that we can kind of move together faster. And this data reporting requirement align likely with the work that's been done in California with JA14, the work that is being done by NBI, and more recently, the work that is being done by the Pacific National Lab, who are also one of our great collaborators. And some of the details, these are some of the details that we're involved in there, of going from site information, system information, control method use. For those, we know at some point there's might be need for system sizing and modeling tools. We also like to learn about that from like the real life scenarios. And lastly, more important, a lot of data in terms of the capacity, the temperatures, and so on and so forth. The goal is to collaborate on this data from real life installation, so that we feed back to the programs and systems that are being developed and quickly improve them and optimize them for the customer's benefit, but also for grids benefit. And for that, we need really a lot of the things that are happening today, especially with the forum. We need to be able to, and for that, that's kind of why we're trying to go with the mantra of going further. But for that, we need to go together and collaborate along the way. So with that, I would like to pause there and thank you all for coming today again. And like I said, we have 2 great speakers that will be talking about the design side of the programs, but also the systems. And I'll be pausing here and then handing over slowly to our next speakers of the day, who will be Colin Collins, who's from Cadio and a senior associate at Cadio, and she has over a decade of experience providing innovative solutions for energy efficiency clients and operating in a range of market with a variety of technologies. She currently leads manufacturer engagement and stakeholder outreach for several commercial HVAC initiatives. So today she'll be talking about guidance on commercial heat pump water heating program design and the next steps that they're working on. Thank you and welcome to, please help me welcome Collins.
Hello, thank you. So I'll get started. Yeah, I'm Colleen Collins from Cadeo, and I'll be talking about commercial heat pump water heater program design and guidance, as well as next steps today. So we'll get right in because there's a lot to discuss. Go over what are commercial heat pump water heaters. I will present a midstream program design roadmap, and I will also provide additional resources for where you can learn more. So what are commercial heat pump water heaters? For the purposes of this presentation, I am considering commercial heat pump water heaters to be central domestic hot water systems. Many of you are likely familiar with the heat pump or the integrated or unitary heat pump water heater as shown here with the heat pump on top and then the storage tank below. Commercial heat pump water systems also have a heat pump and storage tanks, but the systems we're talking about today are not configured as a single unit, but are usually multiple components. Let's see. So the traditionally central domestic hot water systems utilize boilers to generate hot water for a whole building. It's important to understand that with commercial heat pump water heaters, the design and operation is different than traditional central boiler systems. And to understand these differences, we're going to look at two key functions of the central domestic hot water system. The first being the primary water heating, and the second being temperature maintenance. So primary water heating is the process of heating cold incoming water for domestic hot water use in buildings. It's important to note that heat pump water heaters need to be sized differently than traditional boilers. Unlike boilers, the heat pump water heater isn't sized to meet the sudden or peak demand loads of the building. Instead, it's sized to produce lower volumes of hot water, but over an extended period of time, often operating up to 16 hours per day. And during that extended runtime, the heat pump water heater will produce a large volume of water that will be sufficient to meet peak demand. But this also means that the commercial heat pump water heaters need more hot water storage than traditional boiler systems. And then on the temperature maintenance side, so domestic hot water systems have temperature maintenance to compensate for heat losses and water circulation loops. So often commercial domestic hot water systems have long distribution lines that circulate hot water continuously throughout the building. And while that water is circulating through the distribution pipes, it's basically acting like a giant radiator and cooling off the water. And depending on the distribution design and the domestic hot water load profile, those losses can be significant. So, with a traditional central boiler system, the temperature maintenance is addressed by bringing that cooled water right back into the storage tank or boiler to be reheated. However, this is not an ideal approach for heat pump water heater systems, as the single pass heat pump water heater operates most efficiently when bringing in cold water, so that incoming 50 to 55 degrees, and then in a single pass raising the temperature up to the hot water setting, often up to 60 degrees temperature difference. And so if you had that warmer water, return water being piped into the primary storage tank, you'd get a mixed up tank. So it would be all warm. Which is not ideal for these single pass heat pump water heaters. You want temperature stratification with cold water at the bottom, hot water on top, and a very thin sort of warm water layer. So in commercial heat pump water heater systems, the design is to have a separate temperature maintenance system where that return water is pumped into its own storage tank. And there's a variety of ways that you can reheat it. This example is showing a multi-pass heat pump water heater that brings the water through and incrementally brings up that water temperature to be reused in the circulation loop. So now that we all are more on the same page as to what we mean by commercial heat pump water heaters, we'll dive into the midstream program design roadmap for this type of technology. And we'll highlight 4 key components: market engagement, savings methodology, demand response, and cost effectiveness. As we go through the rest of the slides, we're going to be referencing back to this example midstream program, which is to help illustrate the key concepts we'll be talking about. So keep in mind that when we reference back, we're considering a program, a hypothetical program in Seattle, Washington, which would have a local utility of Seattle City Light. And we're focusing that program on multifamily buildings and new construction. So market engagement. I think we're all very familiar that there's a lot of market actors in this industry, with the manufacturers making the products, their distributors or manufacturer reps who are selling the products, and then design engineers who are designing the buildings that specify equipment needed, and building owners who are making final decisions and have requirements for their building. Um, for midstream program engagement, the primary utility engagement is with the distributors or manufacturer reps to sort of maximize market penetration. So the distributors who are already getting training from their manufacturers on the product also have existing relationships with design engineers, will be getting training from utilities on program requirements and incentive levels, and then sharing and helping design engineers specify qualified equipment so they can provide a discounted product, and gather some project detail information that is then shared back to the utility for savings purposes. On the previous slide, we mentioned training a number of times. Training is critical. I'm not going to go into detail because the next presenter will be talking a lot more about this DR Learn platform, but I do want to highlight this is our first call out for our example program. So for our example program, it would be the program would be providing participating distributors free access to the DR Learn platform and also allowing them to share access with up to 5 design firms so that there's some really good training materials pre-existing for that program to onboard with. Also very important for our program is certified products. Fortunately, the Northwest Energy Efficiency Alliance recently published their advanced water heating specification. In version 8, it includes a section covering commercial and multifamily water heating systems. Utilizing NEA's QPL will be critical for the success of any midstream commercial heat pump water heater program. What's really important about this specification is, if you notice, they're rating equipment on a system COP. So it's a whole system. It's not just the primary water heating heat pump or the temperature maintenance heat pump. It's the whole system and how it operates together. And so that's really important to ensure that everything works as expected. Additionally, NEA and other industry leaders have worked over the last few years with manufacturers to get widget or plug and play like systems. So even though there's many components, they're designed as a system and sold as a system and listed on the QPL as a system. The advanced water heating spec has 4 different tiers for this equipment based on efficiency thresholds, and it varies depending on climate zone. If you want more information, the specification, there's a link in the slide deck. And NEA expects to have some products listed on the QPL by the end of Q2. And then our example program is showing products must be listed as tier 2 or greater on NEA's advanced water heating QPL to be eligible for incentive. Also, as we mentioned previously, capacity sizing for these systems is different. Luckily, there is a tool that's available. It was developed by Ecotope, and it's available on the web. And there's a lot more information on how to use it at their website, as well as the background code. But you can input specific information about multifamily buildings, even some load shifting demand response information, and get an output of how to size equipment. And this can be exported in a PDF. Ecotope is looking to expand their tool to include other market verticals, to include more heat pump water heater system combinations. There's currently 3, and to provide more flexibility for thermal storage and sizing in the load shifting area. So they're looking for funding to be able to do that. But right now, it's a great tool for multifamily. And our example program would require projects submit PDF documentation of the sizing and EcoSizer or an equivalent tool to make sure the system will operate as needed. So savings methodology, always important for a program. Typically, savings start with formulas and inputs that may vary based on region. It might need to be an energy model. This example is showing a basic savings calculation for water efficiency with three key inputs. The first is the system efficiency, so going from your baseline to your newer installed efficiency, your your water usage of gallons per year per apartment, and then your hot water change. So how much are you having to heat that water? And then down here, we noted the sources in our table as to where this information is coming from. System efficiency baselines are typically deemed in midstream. Efficiency minimums will either be deemed based on minimum participation or taken directly from a QPL. And then water usage and temperature are taken from regional sources like a technical reference manual. And with our example program values, we have some here related to that Seattle program with a split baseline based on some code, both with central system and an assumed electric and unit system. The three different tiers based on NEA's spec, or specification. And then our example program, you can see there's significant savings available for this technology on a per apartment basis. Tied to savings is the incentive structure. So it's always important to keep incentive structures simple. It's helpful for distributors and customers to easily be able to understand the incentive, as well as to know early in the design process what that incentive will be. We're recommending a per apartment incentive as opposed to a dollars per ton of heat pump capacity or dollars per gallon of storage capacity for two reasons. One, the capacities may vary throughout program design and won't be known as early on as potentially the dwelling units. And as well as we don't want to artificially inflate the size of either to try to maximize incentive. We want the systems to be designed appropriately for the space. And our example program based on previous savings have a per apartment incentive amount based on the three tiered efficiency thresholds. Demand response. So why demand response? Commercial heat pump water heater systems represent an ideal demand response technology. The water storage tanks act as thermal reservoirs that are really good at providing load shifting or curtailment of load. Also, having that central system helps aggregate the diverse loads, so it's more predictable. And the water heating doesn't have to occur at peak demand, so it's really easy to optimize the whole system for demand response events without having little or no impact on customer comfort. And then why do programs need to consider demand response? Adding controls and hardware during installation is much cheaper than trying to add them later or retrofitting the system. Also, sizing the tanks is important to have enough storage to ride through load shifting, and doing that during initial design is much easier than trying to add it later. And then it can also be a benefit to business owners or for the business case when adding in demand response benefits. And our example program would provide bonus incentives for including DNR ready controls at installation, as well as sizing the system to accommodate load shifting. And last but not least, cost effectiveness. Where will commercial heat pump water heater systems be cost effective? Cities or regions restricting or eliminating natural gas in new buildings already have built in demand for these systems. Utilities or regions with portfolios that have greenhouse gas reduction targets. This is a good technology for a portfolio trying to hit those targets. It's a good technology for regions that are in need of or looking for more demand reduction or load shifting opportunities. But regardless, always cost effectiveness tests are always needed on a case by case basis using utility specific methodologies and regional inputs. Where can you learn more? So we've talked about a number of the links on this slide, but a few we haven't. The Advanced Water Heating Initiative is a group that's done a lot of work on both residential and commercial water heating and have a lot of good resources at their website. Bonneville Power Administration, on their Energy Efficiency Emerging Technologies website, they have or will have shortly about 15 commercial heat pump water heater case studies posted. We've talked about NEA's advanced water heating spec. The EcoPort is the control technology that's part of the specification, and there's a link for more information on that. We touched on the EcoSizer, and there's a lot of information available there. And then Lighting Design Lab has a few course recordings if you're interested in seeing a example of what the DNR Learn platform has in as far as instructor-led trainings, which you'll hear about more in the next presentation. And that's it for me. Thank you.
Thank you, Colleen. This was great. Welcome. I wanted to remind folks that they can put some their question in the chat as we progress. But for myself, I wanted to thank you for this great presentation first. And it was good to see some of the tools that folks are discussing in our committees. Nia and is one of our members. And then the EcoSizer tool that you mentioned is a great tool that our members appreciate. It was funded by two or three of our members, including Nia and Smart and SE. So using those tools and feeding back the information or sharing the lesson learned is great. It would be great. So I had one question while we not other questions. I wanted to ask one question to Colleen before we move on to our next presenter. Essentially, I think I just made a few notes here, but I wanted to maybe make it a two-part question. But could you maybe tell us some of the pilots or program that kind of informed, like the strategy that you're proposing? And then the second part of that will be, we're very interested in the DR component. I have one of our committee members that's been calling it the thermal battery, which everybody was like, "Ooh, that's a cool name." But making it happen in real life, it can be a challenge. So I wanted to hear your perspective on some of the challenges related to that. In my mind, I'm thinking about, availability has been an issue already in the market, but beyond that, there might be others with regard to the customer role in this discussion or the program's role in this discussion. So I'll pause there for now. I see other questions coming, but I'll make note while you're responding.
Yeah, so first, so Cadeo doesn't actually implement programs. We're a consulting firm, and we were brought in to help figure out a good way to roll out a program like this. So we don't have any pilot programs we can particularly point to. We did a lot of research and sort of evaluation of where things were and felt that this technology is, with all the tools existing, is at a good point to start piloting. And we're hoping that either through this presentation or others, some people will be more interested in actually piloting the program and answering some of those questions. And it's just sort of based on our experience implementing, or we don't implement, but supporting other sort of pilots and sort of more complicated technologies than potentially lighting. And so a lot of that background went into this. And then I'm sorry, I forgot, what was your second question?
Yeah, no, the second question was a bit more general, but one, and the reason I'm asking this question is we understand the potential that the DR, for instance, focusing on the DR, the DR potential, but how easy or how difficult will it be to get access or control on those systems when they're installed at the customer?
Yeah, that's a really good question. And so that's something we started looking into, and it's unfortunately, it's a very case by case basis. It really depends on where you are. We do know it is expensive to add those controls, so you do need to help cover that. They're not just going to be installed for fun. And then it really helps. Everyone wants to know what the program is. So if there's an established DNR program where it's really easy to show that business case of if you participate or have different load time of use rates, here's your actual savings. So that helps with the sort of business owner end of it. But there are softwares and technologies to add those controls in, but it's definitely still at a price premium. And so that's why we're recommending utilities consider it now, because the system's going to be there for 20 years, and
Yeah.
even if you're not quite there today, if you're there in 5 years, it's going to be a harder to get that change than if you sort of plan for it now.
Great. That's a great perspective. I think I have one last question before we move on.
Mhm.
And this question is from Chad Sambon, who was asking about what is the geographical location that the program is targeting. And I think you touched on it briefly, but I wanted to understand if there was a limitation in terms of geographical location or perspective.
Yeah. So Cadeo has looked at a number of regions, as we noted, sort of on the cost effectiveness. We've looked at areas like Seattle that have some gas bans going in. There's a number of places in California that we've looked at, and the Northeast also has some greenhouse gas metrics that they're looking at, and sort of trying to cross-reference that with where the technology is currently available. So we're not planning to implement, but just trying to synthesize this data for the market to get it out there and to sort of help get over that hurdle of like, what do we do next, and help those regions get to that next level.
Thank you very much. I really see a lot of value in this work, and you can expect some calls from me myself, but many of our members will benefit from this. Like I said, Nia and Seattle City Light, and some of them are our members, but it seems like you've done great work, and I look forward to talking a little bit more. So we'll be noting more questions and catching back in the Q&A. But before, and then our next presenter right now will be John Morris, who will be coming from DNR International. He's a senior director of emerging technology there. John is an expert at helping utilities of all sizes, from rural electric co-op to large IOUs. Helping them understand and prepare for and promote new technologies for energy efficiency and electrification. So heat pump water heaters is definitely in his alley. It's been a new technology that everybody's been struggling with on our side with programs, but we excited, and I'm looking forward to John telling us a little bit today about I think specifically we'll be talking about midstream midstream market transformation for commercial water heating. Hi, John. Welcome.
Everybody, thank you very much for that introduction. I appreciate it. Just want to make sure before I go, everybody can see my screen okay? Sounds like it. I'm going to take that as a yes. Yeah, so as the benefits of going third on any panel, you definitely have some overlap in terms of the conversation. And what I'm going to do really is kind of provide some elements of a market transformation design concept here, but I'm also going to kind of do a bit more of a deeper dive on some of the educational tools that we've been working on to get out into the utilities' hands, so they really don't feel like they have to start from ground zero on this effort. So basically, again, John Morris, been doing energy efficiency work for about 18 years, started in the residential sector. It kind of detoured into transportation and agriculture for 3 or 4 years, and now I'm back in on buildings. So good stuff. I'm really pleased to be here, and I wouldn't be here if it weren't for a lot of really good work that's being done by so many organizations. To name Bonneville Power Administration, Northwest Energy Efficiency Alliance, Ecotope, NBI, AWHI, Cadeo, obviously, CEE. It really truly is kind of all hands on deck here to understand how commercial heat pump water heaters work, to be able to kind of articulate all of the benefits that the technology represents. Cannot do it alone. And I'm just truly impressed by all the collegiality and the partners that have come together to do a lot of heavy lifting. And I think it'd be remiss not to really highlight Ecotope. I think they've been working on this particular technology for over 10 years and developed a lot of really important tools to make sure that these systems are designed right and going in correctly. So again, I kind of feel like, we're at the tip of the iceberg here in terms of all of the great work that's being done, but we see the technology really as something that drives energy savings, can reduce carbon emissions, and so that's kind of an interesting inflection point from an energy efficiency standpoint. Now we're looking at technologies that can do both. We have qualified products with target applications for commercial heat pump water heaters. We're establishing best practices for utility programs through a lot of, like I said, work done through our partnerships. And then we have the education, we have the engineering qualifications, and we have the communication resources ready to go today for those utilities that are really ready to kind of take a serious look at the technology. So why would a utility decide to choose commercial heat pump water heater systems? Well, I'd say first of all, it's really about evolving policies. Evolving policies at the state, municipal level. We've heard about gas bans that are happening in my state. I'm from Portland, calling in from Portland, Oregon today. Eugene just passed a gas ban there recently. So it's happening up and down the West Coast. It's happening on the East Coast and other areas of the country. So that's certainly a technology that can start to solve for those problems for new construction. Also, codes are changing, and so commercial heat pump water heaters can make sense there. They are becoming more flexible. We've talked about those fully packaged plug-and-play systems that really we're seeing are ideal for multifamily buildings, restaurants, lodging, and schools. Commercial buildings with hot water needs. These certainly are a good fit. That's where we'd recommend. We'll talk about that a little bit later. The energy savings that we're recording and tracking is enticing for sure. Reduced water heating energy up to 70% and total building energy by up to 20% compared to conventional central gas or electric systems. Obviously, we've heard from other panelists prior that we actively are soliciting and trying to get more data to validate the initial early returns on the technology. So more data, the better. And the more we can get these systems kind of in the wild, then we can really see how they operate and the benefits that they deliver. And Colleen just did a great job kind of articulating that demand response added benefit. So we think that is also really a compelling dimension to the technology. So we certainly want to encourage getting those systems installed right the first time so we don't have to go back and retrofit them with the necessary communication protocols. So I want to kind of walk through a market transformation cycle that we would see and have seen historically across multiple technologies. NIA is one of the first clients I ever worked for back in 2004. So we understand kind of how MT happens in the Northwest, and luckily we don't have to really reinvent the wheel here. We can take all the lessons learned from bringing new technologies to market and apply them to this one here. And we've kind of talked about you want to work with those manufacturers to educate the local market and ensure inventory. We do have robust relationships with those manufacturers today. Our team just completed a round of interviews with a number of them to understand kind of what their objectives are and how they can help us kind of create the technologies to fit for the climate and weather zones. So we feel like those relationships are robust and in place, and they're going to really accelerate adoption. We want to engage multifamily building owners to deploy demonstration projects. And again, this is something where it's not necessarily limited to new construction. This is also a retrofit scenario as well. And I'll spend some time today kind of talking about a retrofit project that got done in Seattle. Training the engineers, the contractors for properly designed and installed systems. Again, the core of any MT program is around education and outreach. And you'll hear me kind of reiterating that theme over and over today in my presentation. We want to track the data and performance in the systems in the field. So we want to really see how these systems operate and confirm that they are delivering the savings that we are projecting them to do. And then demonstrating cost effectiveness to define the measure as utilities look at how much savings is achievable. we want to make sure that the incentives are structured correctly based on the price it takes to get those technologies installed. And really, this is something where to unlock all of the benefits of the technology, I think it's going to require utilities to really kind of break out of silos. So, this isn't just limited to your efficiency program. It's not limited strictly to your demand response program, but it's kind of a bundling of those benefits and telling that story in an effective way to decision makers that they're going to recommend a program moving beyond pilot and into full-scale implementation. And then ultimately making code recommendations based on the number of technologies that have been installed in any given region or state. So we want to say, look, we're getting them in, we're seeing the data come back, it's positive, favorable, and now we want to start building that into code for the next code cycle. So that's really how we see the evolution of the commercial heat pump water heater through the market transformation cycles. And for us, we kind of wanted to talk about program design recommendations, and we hit on midstream. That's certainly an element of it. And I think Colleen did an amazing job with her slides around program design recommendations. So I'm gonna just kind of sprinkle in a little bit of color commentary in addition to what Colleen had provided earlier. But we really see the commercial heat pump water heater as a measure for existing multifamily new construction programs. So we want to talk to utilities that have robust goals in that particular segment and help them understand how the technology can be deployed within that program. We'd also want to work with utilities that already have existing midstream programs. So if they're already working with manufacturers on residential, and we'd want to not build this thing from the ground up. We want to see what utilities already are kind of working in that midstream lane and add this technology into that. So we also recommend combinations of multifamily and demand response programs to maximize that full value of the technology. And we're not even really talking about carbon emission reductions that could be also layered in as a benefit. It's interesting to me I talk to utilities across the country on a regular basis, and carbon emission reductions are coming up more and more frequently in kind of the priority list for utilities as they think about their programs moving forward. And we have thought about carbon emissions, particularly when the Clean Power Plan was being proposed many years ago, and thinking about how to blend carbon emission reductions with efficiency. And now we've got a real technology that can tell a story in a way that, other than transportation electrification, we haven't really been able to. So I'm really bullish on the ways that this technology just checks so many boxes, right? You've got the DR, you've got emission reductions, and you've got efficiency. And it's really, I think, going to be putting some upward pressure on regulators as well as other decision makers to really crystallize all of the benefits that come with the technology, and then right size the incentive to kind of tell that story. We want to leverage those existing relationships that the utility has within their multifamily new construction programs or their multifamily retrofit programs, along with midstream, to launch these education initiatives. And really by that, we mean, okay, so if you've got these programs, you probably have trade allies, you probably have contractors, you probably have distributors, and those relationships most likely already in place. We can just insert the educational platform directly into those programs and rapidly get decision makers up to speed on how the technology works and how to get programs launched. And then again, leveraging these existing tools that Colleen had provided links to already. And this is really something where the utility is not starting at ground zero. There's been, again, a lot of work done by key partners across the country to really make this a manageable task. So if you're a utility program designer that's in this presentation and you're thinking about this technology, just be sure to know that there's a ton of smart companies and organizations that have really kind of dug in and done a lot of heavy lifting for you already. We talked about the qualified products list, so I just wanted to kind of create a little bit of a snapshot here and kind of differentiate between the standalone technologies and the plug and play systems here. And I know that there is some small font, so for those that have readers, you'll probably want to pull those out now. But again, you can reference this slide on your own. Just due to time, I probably won't do much of a deep dive other than to say, the manufacturers are really providing us with a number of options here. And then we have NIA's advanced water heater spec, which also helps articulate the best applications for the technology in the field. So we do have a robust market engagement set of recommendations, and it's really about, focused on that education and outreach. It's understanding kind of where the market is, where they are today. And I know there was an earlier question about what are the target markets. I won't say it's really a Rubik's Cube, but it kind of is. Again, you really do want to find those areas in the country where code and policies are changing. There's carbon emission reductions as a stated objective. You want to make sure, again, that these technologies are available in any given part of the country. And so when you can kind of check those boxes, it starts to fill out the map for you. I'd say, there's certainly West Coast, East Coast pockets. And we also know that there are others throughout the country, but we feel like there's certainly easier markets to kind of have this conversation in today. So we have the marketing material, which I'll show you in a moment. We want to deliver these educational tools and classes to all of the key stakeholders. We want to continue to enhance those working relationships with the manufacturers. So as they continue to evolve the technology, we can, educate on it. And then as a key part of all of the classes, again, the tools and the engineers from Ecotop are right there with us in terms of delivering all of the necessary information. So here's just a quick snapshot of the Jackson Apartments. This is, again, one of the buildings in Seattle. But for those of you that just need kind of that quick one-pager overview of, okay, what is this? How did it work? What were the key takeaways? We've got those types of materials for people that just really need, at the 10,000 foot level, what is this technology? How did it work in Jackson Apartments? And where can I go to learn more? This one is our virtual interactive tours, and I'm going to probably shift over to a live version of that. But here we actually have created a kind of a platform where learners can hear directly from the experts. So we've got Lester Terrence. He's one of our master HVAC instructors. And then we have Lucy Huang she's an engineer at Seattle City Light. And then we also have Scott Spielman from Ecotop. And it's actually pretty cool because at any given stage, they're actually presenting material within the virtual interactive tour here. So again, I'm going to try to show you really quickly the thing link and give you a sense of how we do these site tours. So you can actually, all of these buttons have information and you can move around the building at your leisure here to learn more about the technology. This is the Steffes Origin, and it's on a rooftop here. So this is a retrofit. If I wanted to click and learn more, here's the Mitsubishi QAHV feasibility study. And if I wanted to read that feasibility study, I could literally download it right there. If I want to go in and enter the skid, I can do that. And now for those of you who might have a little bit of claustrophobia, it's a tight space. I get claustrophobic just looking at this picture. But every element of it has information that people can go and learn more about. And so it really is very interactive. Anything that's got an information button, you can go and get all of the information that you need. And there's actually even videos here. So if someone needs, a walkthrough, you can quickly play a quick
Scott,
video.
It's a little tight in here. Can you tell me where we're at?
Yeah, it is pretty tight. We are inside the rooftop skid at Bayview Towers. We put it on the rooftop in a location where there's no windows on the wall next to it, which will minimize disruption to the tenants from the small amount of noise that the heat pump makes.
So I just wanted to quickly show you that. And again, you can even move into different elements of it, of the building. So here's a whole different room where they did the retrofit to, leverage the existing technologies that were already in there to design the system. So very, very robust set of tools here with the virtual interactive tours. And we've got these tours that are available for a number of different apartments that have been done in Seattle. So with that, I'm going to just jump back right into the slides really quickly. Let's see here. Bear with me for a moment. We also have videos of experts. So these are folks that have helped with design of the buildings, and you can learn more about what they do and how they've contributed to different field installations. And then we also have a whole suite of courses, and these are virtual instructor-led courses that are available to to any utility that wants to go ahead and train up their key stakeholders. So we have folks like Lester who will go ahead and give courses. He'll do it remotely, but we have instruction design teams that work with them to get all of the content mapped out and delivered in a really effective way. And then I wanted to also just say we also have online resources. This is the DNR Learn system, and learners can go through and pick any of the components that they want to kind of do a deep dive on any of the topics that are of interest to them. But ultimately, as we look back on any program and a market progress set of indicators that would say, okay, we've kind of moved the needle here. We'd want to see that installers are increasingly recommending and selling and installing commercial heat pump water heaters units, and we would probably be doing surveys throughout the life of any program to ensure that that's happening. We wanted to see the distributors increasing their stock and sales of the units. Then we'd want to work with purchasers and understand, what level of satisfaction they've had with the savings that they're getting and the performance of those systems in the buildings. And then ultimately want equitable access to the technology. That's something that we believe in 110%. So doing a quick time check, I've got about 2 minutes. Again, another list of those resources that are available. And just to demonstrate that, if you haven't really thought about the technology before today, you really don't have to do much more than to reach out to someone like myself or Cadeo or CEE to learn more. So that's my contact information for anybody that would like to chat about the educational tools that we have available about the technology. And with that, I'll turn it back over to the moderator.
This was great. This was great. Thank you so much, John. Thank you for putting it all together and then also showing the importance of collaboration. And you guys make a good team. So thanks. So I think I have a question in the chat. We can probably, start with as we segue to the group Zoom discussion. I just wanted a quick question from my side is the audience of the material that the educational material you presented, is it mostly the utility or can also, let's say customers that are interested or facility managers that are interested also can use that to a certain extent?
Sorry. Was that addressed to me?
So it was addressed to John, but I
Yeah.
have a next question that is for both of you.
I can. So my first answer would be that it can be for this content could be for end use customers that are going to work to try to get something like this installed, for sure. I think it'd just be a matter of running them probably through an existing utility program with an implementer, and then they can reach out to us and we can kind of help. But if there are people that have projects, we're happy to work with them to get them the information they need.
Great. I'm definitely gonna check that demo out. It looks very cool, and I'm very visual. I don't like to read a lot of documents unless I have to, so that's very cool. I have a question here from for both of you, and it's from Rowan's Cafe. So I'm just gonna read what we put down. It says, "I'm guessing commercial retrofit application will be challenging considering the huge upfront cost of an additional space needed for primary heat pump water heaters and temperature maintenance." So his question is, can each of you share your perspective on how to mitigate some of those challenges?
Yeah, and oh, sorry. I think from John's demo, a lot of these systems they can take up more space, but they don't necessarily need to. Additionally, depending on climate zone and where you're putting it, some of the components can be outside or in a parking garage. So I think there's a lot of potential for retrofit as well. With the focus of midstream, it's just a little more streamlined to start with an entry point of new construction, get contractors, installers, everyone familiar with it before going to the retrofit and trying to like switch over from something else. But if there's an existing central system, there's lots. Ecotope has many case studies that show it's possible to leverage existing stuff and do a lot of different things there.
Yeah, I would just kind of tack on here. It's a great question, and I don't think there's really any way to sugarcoat it. It will be expensive. There will be additional upfront costs. That's part of the challenge of bringing these emerging technologies to the market, right? And we're in that phase where there will be challenges at every turn. But I think that, again, when you can identify those cities and towns where this is going to be a requirement, and so there's this kind of stick effect versus a carrot. The carrot will be hopefully some incentives, because there's obviously benefit from a climate perspective and a savings perspective. But certainly if you're going to be building a new apartment in Eugene in the next 6 years, this technology will be a key part of how you build that building. So again, not to move away from those challenges. They're real, and we have to work with them.
Thank you. We have a minute before switching over. I want to take advantage of that. I know we talked a lot from a domestic hot water perspective. One of in the early days from the pilots, one of the benefits from the pilot, so I don't know if you guys can hear my kids in the back here, but that's virtual meeting. So essentially, we learned that early on, especially in the kitchen application, there's like benefit of cooling, space cooling. So I wanted to know if how will that impact some of the cost factors, and then we can carry on in the next space, but maybe in the next few seconds you can touch on that.
Yeah, so there's if you dive into the advanced water heating spec by NEA, there's several different configurations that are considered commercial heat pump water heaters, and there's some that are more of that unitary type system that you would see, where they would be in the space and provide cooling, and so that is an option. And there's also some work going on to like which system goes best in which place, because while today I talked about the larger sort of central systems, that's not an ideal application for every building or commercial building. So there's a lot of different sort of combinations that you can find in the advanced water heating spec, and it's important to consider all the factors and what design actually makes the most sense for that specific building to maximize the efficiency of the whole system.
Thank you. And John, would like to add one or two words on that?
There's nothing I could add to that beautiful answer. It was perfect.
I agree. So with that, I'd like to take a pause and we'll switch over to the Zoom meeting. But we'll just do some virtual clapping for you guys. This was really great. Maybe I should ask my boys to clap for you. Thank you, guys.
Thank you.
Bye.
Thanks.